Okay, so we are going to start talking about polygons, which just means shapes, and well, I'm going to fill in that right here, but polygons and then the angles that are inside of polygons. Okay, so let's start off with a polygon is a closed figure formed by three or more line segments, but we call those sides. So any kind of closed figure formed by three or more sides is called a polygon. So here in this chart, you see all of these polygons. Well, it doesn't show heptagon, but it shows these four polygons. And we're just going to kind of fill it out and try to come up with some kind of pattern, some kind of rule for the angles that are inside of the polygon. So this triangle, it's got three sides. And wants to know the number of triangles like inside of the whole polygon, which is just one, right? We know that there is 180 degrees inside of a triangle. We've been talking about that almost all year. So the sum of the interior angles is going to be 180. We've been doing that all year long. The angles inside of a triangle equal 180. Okay, so a quadrilateral. Quadrilateral has four sides. Okay, and if we drew this imaginary line in this quadrilateral, then we see that there's two triangles. Okay, well, there's 180 degrees in that triangle and 180 degrees in that triangle. If we added 180 plus 180, there would be 360 total degrees inside of that quadrilateral. Okay, now pentagon. Pentagon has five sides. We can see that there are three triangles inside of a pentagon. Well, just like we did with a quadrilateral, if we have 180 degrees here and 180 degrees in that and 180 degrees in that, if we added all of those together, there would be a total of 450 degrees inside of a pentagon. Okay? A hexagon has six sides. And if you see, this is kind of making a pattern. We see that it's got four triangles inside of it. So just like with all the rest, if we had 180 degrees inside every single triangle and we added all of those together, that would bring us to a total of 720 degrees inside of that hexagon. All the hexagons will have 720 degrees. Okay, so from here we can kind of just continue the pattern. A heptagon is going to have seven sides with five triangles, and that would be 900 degrees. An octagon is going to have eight sides with six triangles with 1080 degrees. A nonagon is going to have nine sides with seven triangles inside of that nonagon with 1260 degrees. And then a decagon is going to have 10 sides with eight triangles inside and 1440 degrees. Now, what if the question asks you what's the sum of the angles inside of a polygon with 20 sides? Well, you would not want to sit here and just continue this chart all the way till you got to 20. So there is a formula that you can use that will help you find the measure of the inside of the angle of any kind of shape. So that formula is the sum is going to equal, you take the sides, the number of sides that the polygon has, and subtract it by 2, and then you multiply it times 180. Now, if you see, that's exactly what we did right here. We would take the number of sides, we would subtract 2, and we would get the number of triangles that were inside of it, and then we would take those amount of triangles, multiply times 180, and that would give me 1,440. So this is just kind of putting our chart into a little bit more of a better formula. Okay, so if for example, let's do number 1. So if I took a 15agon and I wanted to know the sum of the angles inside of a 15agon. It's got 15 sides. That's what 15agon means. So I would take 15 and I would subtract 2 and I would multiply that number times 180. 15 minus 2 is 13. 13 times 180 is going to be 2,340 degrees. Okay, for a 21agon, you're going to take 21, because that's how many sides it has, and subtract 2. And then you're going to multiply that times 180. Well, 21 minus 2 is 19. So 19 times 180 is going to give you 3,420 degrees. All right, a 48agon. It has 48. Oh, let me make that a little bit better. Okay, so if it's got 48 sides, you take 48, subtract it by 2, and you multiply times 180. So 48 minus 2 is going to be 46 times 180, and that would give you 8,280 degrees inside of every single 48agon. Okay, last one, 36agon. You take 36 minus 2, multiply times 180. 36 minus 2 is 34 times 180, and that's going to be 6,120 degrees. Okay, let's go to the next page. So if something is a regular polygon, if you say that something's a regular octagon, or if it's a regular pentagon, or if it's a regular quadrilateral, that means that all side measures are equal. Okay? And if all side measures are equal, then all angles also are equal. Okay? So if a polygon is regular, that's the word we're looking for. If it's regular, that means its sides are going to be equal and its angles are going to be equal. Okay? So it wants me to find the measure of each angle in these polygons. The first one it tells me is a regular pentagon. Well, I can do the chart, or I can look at the chart, or I can do it with the formula. I need to find out how many total are going to be inside of the pentagon. So if this is a pentagon, okay, I want to know what's the sum of all of the total angles, okay? So a pentagon has 5 sides, so I do 5 minus 2 times 180. That would be 3 times 180, and that equals 540 degrees, okay? That's the total. Now, if all of these are going to be the same, if this and this and this and all of the angles are going to be the same,